Hi there, Ms. Lambs here. Today we're going to show you how the quantitative Benedict solution, known as QBS, be used. So QBS is basically a way of helping us to measure the level of sugar in a solution. So here what we have is we have the stock solution of QBS. So before you use it, you need to dilute it first. So basically, instruction here is that you need to dilute you take 35 ml of QBS plus 100 ml of water. So here we have 100 ml of water. Okay, so I'll go up a little bit. Okay, 100 ml of water. So I pour into the QBS solution. Okay, and then stir it a bit, okay? And then, according to the manuals, what you do is you put 3 cm cube of QBS solutions into the boiling tube, and later you add the solutions in. And here we have 4 solutions. One is H2O, pure H2O as a negative control, low amount of glucose, medium amount of glucose, and high amount of glucose, okay? So here we have, so let's get started. So I can extract 3 ml of it first into the boiling tubes. Okay, so since we have 4 samples, so we just put it into the 4 boiling tubes here. Okay. Now, the good thing about the QBS is that if there's sugar in it, then they would decolorize. So it changed from blue to colorless if there's sugar present. So within the same time frame. Okay, so yeah. Because usually what happens in the Benedict solution is that they will change from blue to green and then red precipitate. So since there's red precipitate, we cannot use the calorimeter to measure the differences, okay, before and after experiment. So that's why we use the QBS. So it would decolorize as the sugar concentration increase, okay? So that means if there's a high sugar level, then we expect it to decolorize in a much rapidly way, okay? So that's how we do it. Right, so next, okay, so we got the QBS in, okay? So into a hot water bath here, okay? And meanwhile, we get the calorimeter ready, okay? So this one is measuring absorbance at red color, so 629 nanometers. Now, if you're not sure which light wave to use, what you can do is you just switch on to the light wave and select the ones that with the highest reading, okay? So that's how we can select the light wave for the calorimeter, okay? If you're not sure, then feel free to come and ask the teacher, okay? Right, so let's get started. So here we have the QBS here, okay, and then let's say I add 3 ml of the sugar solution. Okay, so we have water, water first as a negative control, 3 ml, okay, into one of them, okay, and then I label as water. Okay, put it back, and then next one is low sugar content. Again, low, okay, low, and then pop it into the hot water bath, and then medium, and finally high. Okay, and then I'm going to put it in the hot water bath for 5 minutes. Okay, 5 minutes. Okay, so before 5 minutes, looking like 3 to 4 minutes, already you can see the differences. Okay, so you can see that water still remain blue, low sugar concentration, pale blue, medium, still a bit dark, but still you can see that it's turned white already, and high sugar concentration, you can see that it turned white again. So then what we do is we take this, and then we need to let it cool down a bit before we put it into the calorimeter, because it will be much more sensitive. So we let it cool down a bit. And what I did is I used the pipette to extract the solutions, okay, from that. So here, actually, using qualitative data, we can already see that like when there's no sugar, it remains blue. But as the sugar increase, okay, it actually becomes paler and paler, okay? Now, then we test it. We need to have a quantitative data. That means we need to have numerical data for your IAs. So what we did is we used the calorimeter. Okay, so just now, like we said before, you need to calibrate it with distilled water and then set it into suitable wavelength. For this case, it's red light for the blue solutions. Okay, so I've calibrated already with distilled water. So now let's check out the result. Okay, so I've calibrated already with distilled water. So now let's check out the result. So make sure it is in the clear path. Okay, so there's clear windows in the light path. Okay, so let's see what I have. So for the water one, okay, so it's 0.246. Okay, and then let's try out the low one. Okay, so what I did is I spin it down, so you can see that actually there's some particulate here. So you can see that there's some chalk here, okay. So by removing the particulate, okay, so it helps for a better clarity. So you can see that this one also have a little bit of chalk, okay, so, and so on. Okay, so let's try them again this time. Okay, so still about 0.24 something, 443, okay. And then this time, next one. After spinning, so let's hope that the value will be lower. As we can see, okay, we actually can see with our eyes that actually it's become paler, right? So we expect it to be much more lower in absorbance. This time is much better now. After we remove the particulate, okay, so it's 0.157. Okay, and it makes sense because it's decolorizing, so therefore there's less absorbance values. Okay, hold on a sec. Okay, so after 2 spinning, okay, so then there's the differences, okay, and let's check it out. Okay, so this one is medium, is 0.104, and this one is high, 0.05. So you can see that actually after spinning, we can see that the solution becomes paler and paler. Okay, so I think that's it for showing how we use the QBS. Maybe later we'll show you how we use the centrifugal machine. Okay. Also, just one thing to remind everyone is that make sure you remove the markings on the glassware so that it won't interfere with other people's lab, okay? So otherwise it's very confusing, right? So what we do is we get some propanol or any ethanol, and it's squirt it onto the tissue paper and then wipe it dry. Okay, and then it's gone. Okay, so be nice to each other. Okay, clean up after yourself. Thank you and bye for now.